when you have an equation where you have variables on both sides of the equal sign, your job is to just bring all the constants, which are the numbers without variables, to one side, and all the variables to the other side. So let's do letter B. There's fractions. Oh no, do not worry. Don't worry about fractions yet. Remember, you can undo the division by getting a common denominator. But you don't even have to worry about that yet. Your first step is to gather the constants, which are the numbers with no variables, to one side of the equal sign. Now, personally, I always bring the constants to the right side because I like it when it says x equals a number. So I like the numbers on the right-hand side. So with that, if I draw my dotted line, which are the constants of this equation?
-6 and 1.
-6 and +1. If I wanted to bring all the constants to the right-hand side, which of these two has to move? +1. How do I undo a +1?
-1.
You minus the 1 to both sides. When you do that, this goes away, but you still have x divided by 2 is equal to, you still have 1/4 x. And what's -6 minus 1? -7. You're down 6 and you did go down 1 more. Now that I have this, who is on the wrong side of the equal sign now?
X
Perhaps.
over 2.
The 1/4 x, correct? I want to bring the 1/4 x, because he has an x, over to the other guy that has an x. How do I bring this 1/4 x over?
Multiply.
But can't you just...
Yes, it's currently a positive. It's understood that you're adding -7 with positive 1/4 x. So you're going to minus 1/4 x. And again, don't worry about anything yet. Just rewrite it so that it looks a little bit less intimidating. Equals -7. And now, looking at the blue equation, what do you recall you have to do when you have different denominators? Make them common. What is the common denominator of 2 and 4?
4.
4. Well, this guy here already has the 4, doesn't he?
Yes.
This guy does not. I do times 2 times 2. So this is really 2x over 4, which is the same thing as 2/4 x. And 2/4 x minus 1/4 x is 1/4 x. That's equal to -7. Does everybody see how the x over 2, do you see how the x over 2 became 2x over 4?
Yeah, so x is
2x over 4 is the same thing, and I tried to show you guys this last week.
Is it half?
Yes, but 2x over 4 is the same thing as 2/4 x. They're the same. 2/4 x, right? So if I realize that 2x over 4 is really 2 over 4x, when I do minus 1 over 4x, well, 2/4 minus 1/4 is 1/4. That's where I got this 1/4 from. Correct. You multiply by the reciprocal, which is 4. And when you do that, you get x is equal to -28. Before you even begin, you need to know that you have to draw that little dotted line that shows you the two sides of the equal sign so that you could simplify the left and you could simplify the right, and then you can move things over. One is to distribute the 6, and you get 30m minus 18, and then equals, and then you're going to distribute the 1/3, remembering that when you multiply by a third, it's the same thing as dividing by 3. A third of 24 is 24 divided by 3, which is 8m, and a third of 12 is 4.
Okay, I did that.
From here, we have to try to get all of the variables on one side and all of the numbers, the constant, on the other. That means I want the constants, which are negative 18 and positive 4, on the same side. So I might as well bring this negative 18 over by adding him.
I did minus 8m first.
That's fine. You could either minus 8m or either way you're going to get the same thing. You're going to get 30m. This goes away, equals 8m, he's still there, plus 22. Now you want your variables on the left side. That means you're going to bring that 8m that's currently positive, and I'm going to minus 8m so that he could cross the equal sign. 30m minus 8m is 22m. That is equal to 22. Divide by 22. What's anything divided by itself? M equals 1. 22 divided by 22 is 1. So, you distribute, you combine like terms, you rewrite what doesn't change, and then you solve. Remembering that to bring things over the equal sign, you must do the inverse operation. Once you get down to this red, you cannot say 30 and 8 is 38, because to bring these guys together over the equal sign means they have to be inversed. So that means it would be minus 8.
Yes.
As you have seen, we have solved equations. And what have we gotten as an answer?
Whole
Numbers, correct? You have solved equations where you get x equals and you get an actual number. That means that that number that you solved and received and calculated is the solution. But there's two other types of question solutions that you can have. You could either get one solution where you get, like we just did, x equals 1, for example, or x equals 4, or x equals negative 4. You get an actual quantity, integer or decimal or real number. The next type of solution that you can get is what's called no solution. No solution means that the equation is pretty much invalid because there's no value that's going to make the equation true. For example, if I had my original equation up here, and I distributed, and I got 6y minus 30 equals 20 plus 6y, and then I decided to bring the 30 over and got 50, and I got 6y is equal to 50 plus 6y, hopefully at this level you'd be like, wait, how could you have the same value, 6y and 6y, how could they be equal to each other if one of them you added 50 to it? Or you could continue solving and you would minus 6y and you would have gotten 0 equals 50, which is a false statement. If that happens, it means there's no solution. So no solution is when you calculate the equation, figure it out at the bottom, and you get a false statement, such as 0 equals 50. You didn't get x equals 50, you got 0 equals 50, and that's not possible to have 0 equal to 50. So in that case, your answer would be no solution. That's the second type of answer you can get, where you get a false statement and the resulting answer is no solution. The third type of solution is what we call an identity or all real numbers, or any real number. And basically what this is saying is that any value of your variable would make the solution because the equation is pretty much the same on the left as it is on the right. For example, even though when you first look at this equation down here, they look differently, when you distribute the 5, what just happened? You get 7x plus 5x minus 5 equals negative 5 plus 12x, and then you combine the 7x and 5x and get 12x minus 5 equals negative 5 plus 12x. And then you go to solve, you might add 5, and that gives you 0, minus 12x, it gives you 0. You get a true statement, 0 equals 0. Or you can look at it and go, oh, it's the same thing. 12x minus 5 is the same thing as negative 5 plus 12x. That is what we refer to as all real number or identity.
I remember that one.
You can write either identity or all real numbers or infinite solutions. That's up to you. This is all the 3 types of equation solutions that you could have. You could either get an answer, you can get no solution because it's a false statement, or you can get all real numbers or identity. Look at this one, for example. I'm going to solve this one. 5x plus 5 remains as 5x plus 5 is equal to. The 3 needs to be distributed, and you get 15x minus 12. And then you rewrite that minus 10x. So I distributed. Now you combine like terms. So to combine, nothing on the left can be combined because 5x plus 5 is not like terms. But 15x minus 10x is 5x, and then minus 12. What is the solution going to be in this case?
Oh, it's
And the reason it's no solution is if I minus 5x to bring it with the guy on the left, that cancels out and I get 5 is equal to negative 12. Is that true?
No, it's not.
No. So the answer is no solution. So if you find that the statement you get at the bottom is a false statement, like a number equal to a different number, that's always no solution. As opposed to this one, if I follow through and distribute, I get 6b minus 3, rewrite that minus 7, equals to 6b minus 10. Distribute, combine like terms. 6b stays, but these guys become minus 10. Oh, look, it's the same thing. 6b minus 10 equals 6b minus 10. If I continue to solve this, I would get 6b is equal to 6b, which is the same. So this is called all real numbers. You could also use the infinity symbol. You could say infinite solutions. Either way. So when you get a true statement such as this one, 6b is equal to 6b, you get all reals. A false statement is no solution.
Instead of no solution, can't you just put the little 0 thingy with the cross?
You could write that. I would accept that. That actually means the empty set, which is another set of numbers. But once you get into more advanced math, you'll understand what it means. But yeah, you could say no solution. I would accept that.
for sure.
Yeah, because that's what